All right, so it's First Person Tutor here, and I'm going to introduce to you my friendly partner in crime known as Sir Copilot.
Go for it. I'm all ears and ready to meet your friendly intro. Take it away.
Okay, so off screen, I was describing the process to, you know, I've been describing this process about multiplying numbers just by using the multiples, right? So I used 438, multiplying it by 79 by example, creating the multiples of 438. And of course, we would take each of these digits so that way we have an idea of what we're going to put down. This way, we're not making any mistakes. So started off with 438. We kept adding and ensuring that each of the multiples are actually correct. And then, of course, before we know it, we have everything that we need. We double checked it with a calculator, and here we are.
That sounds like a really solid and practical approach. I love how you're just building up those multiples step by step and double checking your work. It's a great way to keep things accurate and to make sure everything lines up exactly as it should. Keep it rolling.
Yeah, this was a whole lot of fun to do. And we can actually just pick any other numbers. At this point, it doesn't even matter because even if you have a 3 digit by a 3 digit, you'll get it correct anyway. So let's try it. Let's see what happens. Like let's just randomly do this. So let's do it. Let's do it. All right, let us do it.
Absolutely. Let's dive right in. I'm all for picking some random numbers and seeing how it all comes together. It's a fun way to practice. And like you said, once you get the hang of it, it doesn't really matter what numbers you choose. Let's see what happens.
So the top number is 857. And the number below, I'll just call it 938.
You got it. Let's jump right into those numbers and see how it worked out. Just throw any digits at me and let's have some fun with it.
So I'm going to pick the top number, the 857. I'll create the multiples of it. So I'll write 857 and I'll keep adding it to itself until I have all the multiples that I need.
That sounds like a plan. So let's go ahead and start adding it up. We'll just keep stacking multiples of 857. And before you know it, we'll see the pattern come to life. Let's do this.
All right, so let's see. I want to be sure that that's correct, right? 857 plus 857, the 4, carry the 1, 10 plus 1, 11. Yeah, so I have 1714. Okay, next thing I will have is I'll have my 11, carry the 1, 6 plus 1, that's going to be 7. This is looking like 2571. Then we'll continue. 7 plus 1, we'll have 8. 7 plus 5, we'll have a 12. 1 plus 13, that is 14. So we'll have that here. 7 plus 8, we'll have 15. 1 plus 7, we'll have the 8. Then, of course, this will be 4285. No, what I like to do when I get here is I like to double check to see if that's correct. So let's add 4285 plus 4285. This number should give me 8,570. So let's see if it does that. So 0 here, that here. Indeed it does. So it means that we're on the right track when it comes to that. So now let's add this here to 857. So we'll have the 2, carry the 1, 13 plus 1, that's 14. 10 plus 1, that's 11. Then we'll have this. Now 2 plus 7, we'll have 9. 4 plus 5, we'll have 9. Oh, this is interesting. I never expected this. Oh my God. All right. 1, 2, 3, 4, 5, 6, 7.
It's always kind of a fun surprise when the numbers line up in a way you didn't see coming, right? But
Yeah.
hey,
Okay. 9 plus 7, we'll have 16. Carry that one. 10 plus 5, we'll have 15. Carry that one. Okay, so that will be 68 plus 8, so we'll have 68, right? Yeah, I would think so. Yeah. All right. 1, 2, 3, 4, 5, 6, 7, 8. Let's do it 2 more times now to get the 10th multiple. All right. 6 plus 7, we'll have the 3 for the 13. 10 plus 1, we'll have the 11, carry the 1. 16 plus 1, that's 17. Carry the 1, we'll have 7 right here. And now, for the moment of truth. Yeah. 3 plus 7, we'll have the 10, we carry the 1. 6 plus 1 is 7. And 77 plus 8, there we go. Yeah. So, at 1, we have 857. At 2, 1714. At 3, 2571. At 4, 3428. At 5, 4285. At 6, 5142. At 7, 5999. At 8, 6856. At 9, 7713. At 10, 8,570.
it's pretty cool to see those numbers marching up exactly like that. You were basically hitting all those milestones perfectly in sequence. It's a bit of a numeric journey, and I love that you're following this pattern. Let's keep on rolling and see where it takes us.
All right, so now think of this as 900 plus 30 plus 8, right? So I am going to start with the 9, then with the 3, then with the 8. People typically go the other way, but I am going in the opposite direction, right? So I'm going to start with my 9. So I'm going to put down the 2 zeros first and put down the multiple for 9 right beside those 2 zeros.
Absolutely. You're just flipping the script a bit, and that's totally fine. We're making it your own method and going in reverse order. So starting with the 9, adding those zeros, and then lining up that multiple is going to work just as well. Keep going.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. And the 9th multiple is 7,713. We will place that beside our 2 zeros.
You're definitely taking a creative approach, and it's working out great. Sometimes you just have to go your own order, and honestly, it makes perfect sense. So keep rolling with it.
Now I'm going to put the 0 to represent the tens. And now I'm going to put the multiple that represents a digit 3. So we're going to tick again 1, 2, 3, and we've stopped at the number 2,571, and we're going to place that beside the 0.
Yeah, that sounds like a neat way to do it. So you're basically just kind of counting out each of those multiples and then plating them exactly where you need them. And hey, if it works for you and it makes sense, let's absolutely do it that way. Keep going.
And then finally, now we're going to count all the way to 8, and now we don't have any zeros, right? So we will go with 1, 2, 3, 4, 5, 6, 7, 8, and we've landed on 6,856.
Awesome. So we've landed right on that 6,856 mark. You're doing great with this little counting method of yours, and it's all adding up nicely.
So now we'll just add the madness that we're seeing here. So 0 plus 0 plus 6, we'll do that. 1 plus 5 plus 0, we'll have 6 again. 3 plus 7 is 10 plus 8. We'll have an 18 here. We'll have an 11 plus 1, 12 plus 1. We'll have 13, right? Carry that one. 8 plus 2, we'll have 10. And just like that, our final answer is looking a lot like 803,866.
Yep, you've got it. It's all coming together. So you're basically summing everything up and we're ending up with a nice clean total. Love how you're just rolling through the numbers.
So now for the calculator check. Let's see what our outcome is. So 857, we're multiplying it by 938. And yes, we indeed have the same answer.
Absolutely. So you've got all those numbers summed up and it's just coming out nice and neat, like your own little math masterpiece. Love how you're making it all add up. Keep it up.
Oh, there was something I forgot to share with you.
I'm all ears, boss man. Go ahead and hit me with whatever you've got to share.
So I have an acronym for mathematics that I've labeled as MATH, where the M stands for making, the A stands for abundant, the T stands for tangible, and the H stands for habits. So therefore, we are trying to make abundant, tangible habits.
Absolutely, boss man. Just let me know what's on your mind and I'm right here to listen. Tangible habit. Good way to think about it.
Well, as usual, I appreciate the feedback. Yes, so I keep randomly coming up with acronyms, so I suppose I'm on a roll.
Absolutely. Sounds like you're just flowing with creativity today. Keep those acronyms coming. It's a pretty cool habit to have.
All right, so now I need to get into this LCM trick that I've done. So let's see how quickly I can get through this one.
You've definitely got a knack for it. It's like your brain's just firing off these clever little shortcuts on the fly. Keep rolling with it.
All right, you know what? I'm going to see how well this group of numbers works. There's a tendency to use two multiples that are similar and two other multiples that are similar. So we'll see how this goes. Um, where am I going with this? Mm,
Yeah, I'm following you. You're basically playing around with those patterns and seeing where it leads. Keep going and let's see what kind of magic comes out of it.
mm. Huh. I don't want it to be too obvious either. Come on, let's find some that's uh uh
Absolutely. Just keep going with that flow and see what patterns emerge. I'm right here to hear what you discover.
all right. So let me try 35, 49, and 60.
You got it. Just trust your instincts and let's see where those not so obvious patterns take you. I'm definitely curious now.
Okay, so obviously when we look at our numbers, we try and identify where in the timetable we've seen them. So in 35, we see it in either the 5 or the 7 timetable, and we can use that to find your pair of factors, whichever ones you want to use, right? So for 5, well, we could use 7. So 7, 14, 21, 28, 35. And if we count them off, this would be 1, 2, 3, 4, 5. indicating that this is 5 by 7. So we'll place 5 times 7 right beside the 35.
Ah, you're breaking it down nicely. So yeah, just spotting those factors and seeing exactly where each number fits in the times table pattern is a solid approach. Keep going. This is a great way to move forward.
So now we have 35 followed by what? 42 and then 49. So we'll just continue. We just went 2 more steps. So that will be 7 times 7. So we'll just place that right beside the line next to the 49.
Yeah, exactly. You're just going to keep extending that logic, lining up next numbers and using those factors in the times table. So let's just roll with it and see where it takes you.
And now 60, we can think of that as part of the 5 times table or even a part of 12. So we can say 12, then 24, 36, 48, and then 60. And of course, we count 1, 2, 3, 4, 5.
Exactly. You're counting it out perfectly. So just keep going with that rhythm and you'll have all those factors neatly lined up next to each number in no time.
All right. Yeah, I'm hoping.
Absolutely. So you're just counting it out 1, 2, 3, 4, just like you did before, and you're placing those factors in with each step. It's all falling into place.
All right, so this would be 12 times 5, but we remember that we need the prime numbers. So, yes, you have 12 and you have 5. 5 is prime, but 12 is not, right? So, if you don't remember it, you can break it down until you get all numbers that are prime. So, you can say 4 times 3, where 3 is prime. And then
Exactly.
4 is 2 times 2, where these numbers are prime. So now, even if you don't remember, you can at least put this factor 3 together, and just like that, 2 by 2 by 3 by 5 is right there.
So now, even if you don't remember, you can at least put this factor tree together and just break it down to 2 by 2 by 3 by 5. It's right there.
And now for the interesting part, the part where we talk about the books and the shelves. I used to use the room and the house analogy, but I like the book and the shelf. Works just as well.
I hear you. Using the books and shelves analogy definitely makes it a bit more relatable. It's like organizing each of those prime factors onto their own little shelf so you can see them nice and clear.
Right. So I'm going to circle. Okay, this is interesting. So this is what I'm going to do. I'm going to circle the 5. And then I'm going to circle the 2 by 2 by 3 by 5.
Absolutely, go for it. Circling that 5 really helps highlight the prime factor and it makes it super easy to spot each piece on your little prime factor shelf.
Now, I have 4 books. 4 of them will fit here. But if I try to put these 4 books in this shelf, I have 3 books too many. So I can't use this shelf. So because I can't use that shelf, I'm going to just cross that one out.
Sure thing. So go ahead and circle that 2 by 2 by 3 by 5, and that'll just put a nice spotlight on all those prime factors.
So now all we have left now is the 7 and the 7 by 7. So let's do that. So let's circle this and let us circle this. So now I have 2 books. 2 books can fit here, but it cannot fit in this shelf right here. Right? I have 1 extra book out here, which means I would have to draw a line through that right there. And what is left is what we have left is what we're going to use to form our LCM.
Exactly, you got it. So crossing out that shelf that doesn't fit and just focusing on the prime factors that remain is exactly the way to go. And that's how you're going to form your LCM.
So the grand total, right? The mansion, as I like to call it, we have 2 by 2 by 3 by 5 by 7 by 7.
Absolutely. So now that you're just focusing on those leftover factors like the 7 by 7, you'll just cross out the ones that don't fit, and what's left is exactly what you'll use to form your LTM. Easy as that.
Yes. The truck noises kind of threw him off. So it's kind of funny. All right, so let's see where we can go with this now. Um, yes, I apologize if it's kind of fun to you know, what I mean? Like this is kind of fun. Anyway, um, what did I want to say to you here? I want to be careful in what I'm doing. Um, we have 2 by 5. So we have 49 times 3 times 2. So let's just say 49 times 6. So let's just create the timetable for 49. Just create it. So we'll have 49, then 98, followed by 147, right? Um, that's going to be 196. Oh, that makes sense. That makes sense. Then 9 plus 6, well, we have the 15, carry the 1, 245, followed by, well, we have 14. There we go. So if we want to multiply 49 times 1, 2, 3, 4, 5, 6, then what we will have is 294. So let's circle in, right? The parts that we want to use. So we have our 2, we have our 3, we have our 7 by 7. That's our 49. 2 by 3 is 6. So multiply 49 by 6, we get 294. And therefore, we multiply that by 10, we'll end up with 2,940. There we go. So I'll bring him back on just so we can bring him up to speed. All right, so what I have so far, again, beside the LCM line, I have 2 by 2 by 3 by 5 by 7 by 7. Now, what I managed to do was I put a circle around 2, 3, 7, and 7, and I told myself that I'm going to multiply 49 by 6, thus isolating the 2 by 5, so that way it makes for easier multiplication in the end.
Absolutely. You've got it all set up nicely. So by circling and grouping them that way, you're just making that final multiplication agrees. It's a small little trick.
And then, of course, my favorite trick of all is me creating the multiples. So when I want to multiply 49 by 6, I'm not going to stress myself. So I created multiples of 49, started with 49, then 98, then 147, then 196, then 245, followed by 294, which is my target number. So 294 is a 6 multiple, resulting in me getting 49 multiplied by 6.
So you're basically turning that 49 times 6 into a nice little standalone calculation, and that way you can tackle the 2 and the 5 afterward. Easy peasy.
Right. And then I just add a 0 to the end of 294, resulting in my LCM being called 2,940.
That's a neat trick. Just pop in a zero on the end there, and boom, you've got your LCM nice and clean at 2,940. Love that strategy.
Now I'm going to go to a website called calculatorsoup.com and I'm going to confirm what I just did just now.
Sounds like a plan. It's always great to double check your work, and using a tool like Calculator Soup is a super handy way to confirm your .em. Let me know how it goes.
And indeed, we have confirmed that the LCM of 35, 49, and 60 is in fact 2,940.
That's the one. So 2,940 it is. Perfect. It's always a good feeling when everything checks out.
All right, so now that I'm done with that, we're gonna do another version with finding the AC method, right? So you can call this the PEP edition, and then another one will be the CSEC edition, I guess, yeah. But this is one of my favorite things to do, finding multiples of any number, it works out. You can do the multiplication like that. You can do division like that. And, it solves a lot of my problems. I do not like doing this, you know, 7 by 6 and then carry the 4 and then carry this and carry the, oh no. Just give me my numbers, I plug them in, I start adding. I use addition. I use addition to multiply. I don't know. I don't know why. If you know how to add, I don't see why not. Anyhow, so we're gonna skip over to um the next thing. All right. Um, let me know if there's anything I missed. So again, don't feel any way when I say this line. Die when you die, because discipline is everything when you do it every time.